Alright, so today we're going to be talking about inertia of fluids, and one of the first things you want to ask your students is, what is a fluid? They're going to give you a few different responses. One of them is going to be liquids. You want to make sure they also understand that fluids are gases. And then once you get that, then you can pose the question, do fluids have inertia? And they're obviously going to say yes, and you'd say, alright, well, since we're scientists here, how do we prove that? How do we show that fluids have inertia? And they might come up with any number of experiments. One of them that you will likely come up with is to put water in something and swing it around and see if it continues going. That one's a little bit messy, so you try to lead them in a direction and try to get them to have something to measure it by. How do you know that this fluid has inertia? What is going to be what's going to be changing? What's going to be our indicator that it has inertia? And so here we have a nice little demonstration that demonstrates inertia of fluids very well. And so you can pose the question, alright, since we're scientists, we're talking about inertia of fluids, which way is this little floaty bobble thing going to go when we spin it? So you're going to ask for a vote if it's going to go out, ask if it's going to go in, stay put, not do anything, and then you start to spin it, and hopefully you can see this in the video, but the bobbleheads, they go in. And then you ask for some reasoning why. Why does that happen? And we might actually get a little close-up on this here in just a little bit later. But for now, you ask them why are the bobbleheads going in? And you're eventually going to get the answer that it's because the fluid has inertia, or the water itself is moving to the edge, and so that's pushing this bobblehead in. And because the bobble has less inertia than the water, it moves in. Another way to think about this is, where's the pressure the greatest? And you think about the pressure is going to be the greatest on this outside edge. And because of that, it's going to force the bobble to go to the area of least pressure because it's less dense or has less inertia than the rest of the material. Good. Alright, here's a close-up of that apparatus that I was talking about. It's a pretty simple design. If you see from this, these are just two jam jars that have been secured down to this pivot point, and they're filled with liquid, so that way when you spin it, then your bobble moves in and you're able to see that very nicely.